the intersection of subgroup. If you have two subgroup, then the intersection of those subgroup will be a subgroup. Intersection of subgroup is a subgroup, but union will not be. For example, here you can notice, if you take Z plus, this is a subgroup, this is a subgroup, but their union is not a subgroup. You can check it out. Tell me why their union is not a subgroup. See, if you take Z plus, okay, so you know that you have this subgroup 3Z plus, this is also subgroup, 4Z plus, this is also subgroup. So both of them are subgroup. Why their union is not a subgroup, but their union, these are subgroup. Now you take their union, means 3Z union 4Z. You take their union. Is this a subgroup? Is this a subgroup? You take their union. So here you have multiple of 3, here you have multiple of 4. If you take their union, is this a subgroup? Is this a subgroup? Tell me. Here you have multiple of 3, here you have multiple of 4. These are the subgroup. If you take their union, will this be a subgroup? No. Why? What is the reason? This is not even closed. This is not even closed. This is union you are taking. This is not even closed. For example, 3 plus 5, 3 plus 4, that does not belong to this union, right? Right? Yes or no? This is not even closed, because 3 plus 4, that is 7. That does not belong to this base set. So this is not even closed. So I can say union of two subgroup, that need not be subgroup, correct? So this statement I can say, for any group, the union of two subgroup, that may not be a subgroup. But intersection of two subgroup will be subgroup. If you take two subgroup, their intersection will be subgroup. Why? Let's see. If you have, let's assume you have a group. Let's see how we can say this. Let's assume you have a group G comma star, and let's assume you have two subgroup. You have two subgroup. One is H comma star, and another is, let's assume another is some J comma star, whatever, L comma star. Now tell me, you have two subgroup. Can I say their intersection will be the subgroup? Their intersection, H intersection L star. Yes, this will be a subgroup. This will be a subgroup. Why this will be a subgroup? What are the things you need for subgroup? The first thing is, can I say identity element will be there? Can I say we have identity element here? Can I say we have identity element here? Yes, of course. Because you know that identity element belongs to H also, identity element belongs to L also. So identity element will be in the intersection also. So identity element is done. There is no problem. Identity element is done. Let's see closure property. Let's see closure property. If you take two elements in H in intersection L, what it means? If you take any two elements in H intersection L, then what it means? Then can I say A star B belongs to H intersection L? This closure property. So you can notice, if you take two elements in H intersection L, if you take any two elements in this, can I say A star B will be in this? Can I say A star B also will be in this? Basically, this is my, I want to check whether this is subgroup or not. I want to check whether this is subgroup or not. I want to check whether this is closed or not. I want to say that identity element is or not. And I want to say that inverse is or not. So can I say this is closed? Yes. Because from this I can say that A comma B belonging to H. If A comma B belonging to H and A comma B belonging to L, it means A B belong to H. It means AB belong to L. It means AB belong to H intersection L. Yes or no? Very simple. Isn't it simple? Like this proof, very simple. You take any two elements in this, and you can say that their operation will also be in this. So if you take any two elements in this, then I can say, because it is intersection, So A comma B will be in H, A comma B will be in N. And because this is a subgroup, so this is closed. Because this is a subgroup, so this is closed. It means AB belongs to H. It means AB belongs to L. So AB belongs to H intersection L. So this is closed, right? Yes or no? Closure property is also there. And what about inverse property? If you take any element here, then can I say A inverse will also belong to this? If you take any element here, then can I say every inverse will also belong to this? Yes, of course, because this implies that A belongs to H, A belongs to L, A belongs to H. And remember, H is a subgroup. You already know H is a subgroup and L is a subgroup. So because H is a subgroup, so A inverse belongs to H and A inverse belongs to L. From these two, A inverse belongs to H intersection L. Very simple proof. That's it. Three things we wanted. Three things. Inverse property, closure property, identity element. Three things we wanted. We wanted three things. All are there. So this is your proof that intersection of two subgroup. If you have two subgroup, then intersection is also a subgroup. If you have any two subgroup, then their intersection will also be a subgroup. But union may not be a subgroup. Okay.